So today we're going to be starting with rotations. It's the third out of four transformations that we're going to learn. And there's three different types of rotations. Well, 90 clockwise, 90 counterclockwise. Yeah, there's three different types of rotation. So this little square here is going to live, not glued in anywhere, but it's going to live inside your little pocket that we all have in the front of our notebooks. Some of them have it at the back. If there's anyone that doesn't have this pocket, let me know at the end of these notes and I can get one for you. But this little square is going to live in there just so we don't lose it and so we can actually manipulate it and turn it when we're working with these rotations, all right? The other thing that's going to go, and this is extremely important, the other thing that's going to live inside this pocket is one of these. It's a transparent slide, which is why the pocket is titled Transparent Slide. It's a piece of transparent paper, bless you. Did any of your elementary teachers ever use like an overhead projector? Yeah. Some of you know what I'm talking about? Okay, so that's what these are. It's where they draw with the little markers and it's like it lights it up from the bottom, you know what I mean? Might be a little before your guys' time, but this is going to be super helpful in our rotations. And this is also going to live inside our little pocket, okay? Now, these transparent slides. Let's listen, please. Thank you. These transparent slides are not cheap. So you each get one and only one for the remainder of the unit. That's why we have these pockets. If you keep your slide in your pocket, you should be fine and you should not lose it. If you lose it, you do not get another one, okay? It will be tremendously helpful, not only on our homework, but on the test for you to have this. So I cannot stress enough the importance of keeping this slide in your pocket where it is safe and where you won't lose it, okay? That's why we have the pocket, for the rotation helper and for the slide. So I'm going to give everyone a slide right now. You don't have to put it in your pocket just yet because we're going to be using them. Please don't draw on the slides yet. I'll tell you what we're going to draw on them, or I should say write on them. They're very easy to lose, especially if you drop them on the floor. So just keep them in your sight. Okay, did anybody not get it? All right, do all have a slide now? Okay, good. Okay, let's go ahead and get started then. So, a rotation. If we take a look back real quick at our vocabulary chart, we can see that a rotation can be defined as a transformation that turns a figure around a given point. Okay, with translations, we're sliding our triangle. With a reflection, we flip our triangle across a line. Now with the rotation, we're going to turn our triangle around a point. Okay, so very similar descriptions, yet also very different. As always, we're going to start simple with just a point. The first type of rotation we can have is a 90-degree clockwise rotation. We're always going to be rotating, luckily, around or about the origin. Where's the origin at here on my graph? 0, 0. I'm going to make my dot right there at 0, 0. And what are the coordinates of that point M that you see? 2, 3. Good. So we're going to graph the image of point M after a 90-degree clockwise rotation around that origin. Here's how we're going to do that. First, let's take a look at our rotation helper. All right? In order for us to determine what we need to do for the given rotation, in this case, like I said, 90 degrees clockwise, is we need to start with start at the top. So this is what the square should look like. Upright, start at the top so you can read it. And you're going to find the arrow that says 90 degrees clockwise, which looks like this one right in here. Okay? We're going to take this little square and we're going to turn it so that 90 degrees clockwise is now up on the top. Is everybody following what I'm doing so far? Okay. Some of you may know what a 90-degree clockwise is turned without using this. That's fine. You don't have to use this, but this is a good help. All right? Now, with our transparent slide, we're going to place it over the graph just like that. All right? We're going to take our expo marker. And the first thing we need to do, as you can see, step 2, draw a plus sign where the origin is. So I'm going to draw a plus sign right over my origin. You guys okay? Okay, let's focus on this, please. We draw a plus sign right where the origin's at. Okay? That's what we're going to do first. Let's go ahead and do that. I know some of your markers are rather thick. If your marker is out, let me know. Okay. Out. Okay. So we've drawn a plus of the origin. Step 3, we're going to draw a dot where point M is, keeping that origin nice and lined up. Boom. There's my point M. I make a dot right there. Right where M is at. Just draw over the dot. That's why the slide is transparent, so we can see what's underneath it. All right? Now, we're going to turn our slide, or rotate our slide to the right one time. So we're going to turn to the right, which is that direction, one time. Here's what that looks like. Turning to the right, turning to the right, turning to the right, and we line that plus sign right back up. That's why we're drawing it. I'm going to show you again. This is where we start. There's my point M. A 90-degree rotation is one full turn. Clockwise means we're going to the right. Boom. That's where we end up. Now, if you don't understand that, here's where our rotation helper comes in handy. We're going to line that up right where it is. We're going to put the rotation helper over our slide with start facing up. And we're going to turn both little squares until 90 degrees clockwise is on the top. So I see right here, this filled in arrow says 90 degrees clockwise. I'm going to take both squares and turn them so that now 90 degrees clockwise is on the top. All right. I take my helper away. All I have to do now is line that plus sign right back up at the origin. And we see that M lands right there. What are the coordinates of where M lands? Can anybody see that? What was it, Ayana? 3, -2. So we're going to write those coordinates down so we know where to make that dot. Or you could hover your pencil over that new placement, move the slide out of the way, and make our new dot right there, M prime. Notice how it kind of looks like a reflection, but not really, because the points aren't lined up, and they're also not equally distant from that x-axis. Here's point M where we started. We rotate one turn to the right, and there's M prime right where we land, or where we end up. Okay, M, turn once to the right, boom, M prime is right there at 3, -2. Quick show of thumbs. How do we feel about understanding that? Thumbs up if that makes sense, easy enough to follow. Thumbs sideways if it's still a little confusing, just fine as well. Okay, good. I see all thumbs up. That's great. You can go ahead and erase your slide, at least the M point. You can leave your plus there if you want. And let's take a look at the second type of rotation, a 90-degree counterclockwise rotation around the origin. What's that? You can erase the point M. It doesn't erase? All right, next one. So counterclockwise, if we're looking at the clock, right? Everyone take a look at the clock. You see that red hand moving?
Yeah.
What direction is that red hand moving? It's going clockwise, right? That's why it's called clockwise. It's the direction a hand moves on the clock, to the right. Counterclockwise would be if all of a sudden time started going backwards and that red hand starts turning over to the left. Counter just means opposite. Has anyone ever played Counter-Strike before?
Yeah.
Okay, a couple people. Counter-Strike means you are striking back, right? So we're going backwards from clockwise, counterclockwise. All right? So point N, where's my pre-image at for point N? 2, 3. It's the same spot as point M. Because what we're going to do here is see the difference in our image point, whether we're going 90 degrees clockwise or 90 degrees counterclockwise. We're going to follow the same thing, same steps. I'm going to put my slide over the graph, draw a plus if we don't already have it, where the origin is. And I'm going to draw a dot right where my point N is at. Now what we're going to do is rotate our slide one time to the left. Clockwise means we're going to the right. Counterclockwise means we're going to the left. Okay? So even if we don't understand that, we put our rotation helper right over it. 90 degrees counterclockwise is right here, this outer kind of not shaded in arrow. We pick them both up, turn them both until 90 degrees counterclockwise is up on the top. Take our rotation helper away and line the origin back up. Okay, guys, my patience is getting real thin right now. And that's where we end up. Again, I'm going to hover my pen over that new spot. I'm going to draw a point right where we're at. Call it N prime. What are my coordinates now for N prime? Perfect, thank you. -3, 2. Take a moment, examine those first two rotations, notice how they're different. Look just how different of a place they ended up. Whether we're rotating to the right or rotating to the left. Let's even go ahead and write in here. Counterclockwise means we're going to the left. Clockwise at the top meant we're going to the right. All right. So those are our first two types of rotation. 90 degrees to the right, clockwise. 90 degrees to the left, counterclockwise. Let's take a look at the third rotation, which is a 180 degree rotation. What are we missing in this third type of rotation here? The direction. Anyone want to guess why we don't have a direction here?
Because 180 is just 290 degrees.
Exactly. 180 is just 290 degrees, right? So take a look. I'm going to use my slide to basically explain what we just said. If I go 2 turns to the right, there's 1 turn to the right, 2 turns to the right, 180 degrees clockwise is at the top. If I start back, now I'm going to go to the left, 1 turn to the left, 2 turns to the left, 180 degrees counterclockwise. So they're the same term. Whether you turn twice to the left or twice to the right, you're still in the same spot. Okay? Does that kind of make sense? Hopefully. So we got point O here. Where's point O at? -2, 4. Good. We're going to graph the image after a 180 degree rotation. And the trick here is it doesn't matter which direction you go. Just rotate your slide twice. I'm going to line up my plus sign at the origin. I'm going to draw a point where my O is at right there. And I'm going to rotate my slide 2 times in either direction. Just for this example, I'm going to go to the right. Here's 1 turn to the right, line that plus back up. 2 turns to the right, line that plus back up, and boom, we're right here. I see that I'm at 2, -4. I'm going to move my slide out of the way and make that point, calling it O prime at 2, -4. So in those 90 degree rotations, hopefully we can see that our image point was in a quadrant right next to our pre-image point. Just so you know what I'm talking about, right? M and M prime are in 2 quadrants that are touching. N and N prime are in 2 quadrants that are touching. But here, our points are in opposite quadrants, or diagonal from each other, because we've turned our point twice over. Right? And the reason why we keep our plus sign at the origin is because we are rotating this around or about the origin. We can think of the origin as like our anchor point, and we're just turning, kind of like a steering wheel around that anchor point and landing in a new spot. O prime is down there at 2, -4. Now this is where things are going to get fun, because it's easy to rotate a point. That's not bad. Let's rotate a whole triangle though, like PQR. Can someone help me out? What are P's coordinates here? Go ahead there. Perfect. 1, 2. Darius, where's point Q at? Perfect. And Tina, where's point R? 4, 2. There we go. So we got all our pre-image coordinates of PQR. We're going to look for our directions, graph the image of the triangle PQR, I know you guys don't have highlighters, but that's okay. I'm going to highlight this just so you can see it's important after a 90-degree clockwise rotation about the origin. Please don't highlight that with your expo marker. You will not be able to read it. And we're going to follow that same process. Slide over the graph. Excuse me. Plus sign at the origin so we know where to line everything back up. And we're going to make 3 points, one at P, one at Q, good morning, and one at R. Now, just so our slides don't get too messy, thank you, we're only going to label 2 of these points. I'm going to label point Q and point R. Why don't we have to label the third point? Because if we know where Q and R are, obviously that last one's got to be point P, right? If it helps, you can, you can label all 3. It doesn't really matter. But what I kind of want to advise against doing is drawing the actual lines of the triangle. Not just because your expo markers, like I said, are rather thick, but because it's going to be a little bit harder for us to pinpoint exactly where my image points are going to be. You'll see what I mean in a second. We're going to go 90 degrees clockwise. Is that turning to the right or turning to the left? To the right. Clockwise is to the right. What are you looking for?
Shape.
5, 6, 7. Here and there. So those 2 little squares are going to go in the pocket. Yeah.
So this goes like on top of it?
You'll see, because we're talking about it right now, yeah. They kind of work together in a way. All right, we're ready to rotate. We're going to go to the right one time. Here we go. To the right, to the right, to the right, to the right, to the right. Once. We line that plus back up. And this is where we have to be careful. All right? We've got 3 new dots to draw. I'm going to put my pen over the first one, point P. I'm going to move my slide and make a point. That's going to be P prime. Then I just bring it back over and repeat. R is right here. We'll call that R prime. And what is that? Q? Q is right there. That's my Q prime. Now I can connect those 3 dots together. And I have the triangle P prime, Q prime, R prime. Question. Are these 2 triangles congruent?
No.
No? Yes, they absolutely are. We did not shrink or enlarge this triangle at all. What did we change, though? The direction. Good. More specifically, a word that starts with an O.
Rotation.
That starts with an R.
Orientation.
Orientation. Take a look. Transformation, our umbrella term, changes the position, the orientation, or the size. All right? With translations, we change the position. With reflections and now rotations, we've changed the orientation. And we'll change the size later this week, maybe on Wednesday. So these are still congruent triangles. However, they've been oriented a little bit differently. And we just went through all of our directions there. So if this is confusing, this process, once we get to the work, all you got to do is follow these steps. They're very easy to follow, very straightforward, and they'll help you get done your rotations. Last thing we do is figure out our image coordinates. Where's P prime? 2, -1. Thank you. What about Q prime? That'll be R prime. Yep, 2, -4. And Q prime? 4, -4. Good. So right away, we're not going to get into this today. We'll talk about it tomorrow. But if we look at P, P went from 1, 2 to 2, negative 1. Q went from 4, 4 to 4, negative 4. And R went from 4, 2 to 2, negative 4. So just as a challenge, see if you can maybe come up with a rule in your head as to what we're doing from coordinate to coordinate. But like I said, we're going to worry about that tomorrow, not today. Today, we're going to practice using our little slides. That's the main goal here. All right, you can erase your PQR. Oops, that's all right. And we got one more note sheet to get through. I'm going to leave that up just for a second. Yeah, when we're done. All right, note sheet number 7, last one. Where did it go? Oh, I didn't glue it in. So we just did 90 degrees clockwise. Of course, naturally, the next thing to try would be 90 degrees counterclockwise, or to the left. So now we got triangle STU. I want to get through this so you guys have time to work. Point S is at negative 3, 1. T is at negative 2, 5. And U is at negative 1, 1. We're going to graph the image of triangle STR. STR? Should say STU. That's my bad. STU, stew, after a 90-degree counterclockwise to the left. That's right, to the left. Counterclockwise, we're going to the left. Around the origin, as always. We're going to follow our steps nice and quick. Slide over the graph, plus sign at the center. I'm going to dot, dot, dot my STU. Boom, boom, boom. I'm going to label my T, label my S. If we know where T and S are, we don't really need to label our U. And this time I'm going to use my rotation helper just so we can get some practice with that. All right, so we've got all our dots marked. I'm going to put my rotation helper over the top with start facing up. And I'm going to turn both of my squares until 90 degrees counterclockwise is up on the top, which would be one turn to the left. See how I'm turning them both at the same time? 90 degrees counterclockwise on the top. I move my helper away, line that plus sign back up nice and easily, and I've got 3 image points right there. Darius, please pay attention. I'm going to move this over. I've got a point there. I've got a point there. I've got a point there. T prime. My S prime's on the bottom. U prime on the top. I connect those 3 dots together, and there is my image triangle. Hopefully you can see and visualize how we're turning this. It looks like our triangle got tipped over onto its side. Because it did. We rotated it 90 degrees. What are my S prime coordinates here? S prime, where's that at? Negative 1, negative 3. What about T prime? Negative 5, negative 2. And U prime is at negative 1, negative 1. Just like that. All right. How are we feeling about that? Okay? Decent? Okay. Last but not least, let's rotate a triangle 180 degrees. Again, When we're going 180 degrees, the direction does not matter. We can go 2 turns to the left or 2 turns to the right. Either way, we'll end up in the same exact spot. So I'm going to line up. I'm going to dot my X, dot my Y, dot my Z. And hopefully you notice we don't need to draw the lines of our triangle. All we need to draw is the dots, because then we just connect the dots and make the triangle. Don't overcomplicate things. Just draw the dots on your slide. My pre-image coordinates for X are -4, 1. Y is at -4, 3. And Z is at -1, 1. Does not matter what direction we're going to go. We just have to turn this twice. This time I'm going to go to the left. 1 turn to the left looks like that. 2 turns to the left ends up there. I'm going to dot my Z, my X, and my Y. Y prime, X prime, Z prime. There's my image triangle. X prime is at 4, -1. Y prime is at 4, -3. And Z prime is at 1, -1. It's an interesting switcheroo for our coordinates. From -4, 1 to 4, -1. From -4, 3 to 4, -3. And from -1, 1 to 1, -1. For X prime, Y prime, and Z prime. All right. What questions can I answer about any of that? Yeah, Ross. Yeah, when Darius is going to go, and then when he comes back, you can go. Go ahead, Darius.